So what I'm going to do now, just to make this example again tangible and concrete, is we're going to walk through one of the methods in the WordSearcher class, which is part of this SimpleSearchStream program, and we're going to see how to visualize its behavior. And again, the whole point of this is to help you get both left brain and right brain juices flowing, so you not only understand how the source code looks, but you also understand what's kind of happening under the scenes with the streams paradigm. So the particular method we're going to look at here is the find words method. We're going to visualize how find words works in our program. And again, you can find all this in my GitHub repository. So what this method does is it takes the input string, which is the lyrics to the Do Re Mi song, and then it takes a list of words to find, and it's going to go ahead and look up the words in the string and come back with a list of results, search results as they're called, where any of the matches occur. So the first thing we do is we take our list of words to find and we convert that into a stream. So we use the stream factory method, and the stream factory method creates a sequential stream in this case. And so we end up with a stream of words, which are strings. So if you take a look on the left-hand side, you can see we start out with a list of strings. Each string is denoted by a little square, gray square. And then we convert that into a stream of strings using the stream factory method. So we now have a stream of strings that was converted from the list of strings. And then that stream of strings gets input into the map method. And map is one of these aggregate operations. It's actually an intermediate operation. And we know it's an intermediate operation because it takes a stream as input and it gives a stream as output. And if you recall, what map does is it's going to go ahead and apply a mapper function using the functional interface to every element in the input stream. So what we're doing is we're taking the list of words and we're going to call this method reference called search for word. And so that will go and look up in the input string to see if there's any matches for that word, for each word in the list of words. And we'll of course look at the details of this later. Right now I'm giving you the forest view, not the tree view. What comes back as the output from the mapper function, search for word, is something called a search result object. And a search result is basically a C+ or a Java object that stores the number of times a word appears in a given input string, if at all. Could turn out that there's no matches whatsoever, in which case you'd have an empty search result. But in this case, we're looking for Do, Re, Mi, Fa, Sol, La, Ti, Do in the lyrics to the Do, Re, Mi song. So of course, we're going to get matches. Probably the most important thing that search results will keep track of is the indices where the match occurred. And that is stored in this little objects of this class called result. And result basically keeps track of the index in the string where the match occurred. So we have a list of result objects that's part of our search results result object, if that makes sense. So notice, by the way, that map can transform the types. So map will take in a stream of strings and it returns a stream of search results. So we'll talk, when we talk about map in a bit more detail later, you'll see that map can do transformations or conversions of types. So it can go from one type to another, which is what it does here. It doesn't have to, of course, but in this case, it does. We then take the stream of search results and we go ahead and run it through a filter. And the filter is another aggregate operation. In this case, it's an intermediate operation because it maps stream to stream. And what filter does is it's going to get rid of any empty search results. Now, for this particular example, we'll never have any empty search results. But if we looked up quotes from Shakespeare in the lyrics to the Do, Re, Mi song, of course, we wouldn't get any hits. So what'll happen if there aren't hits for a particular word is the filter algorithm will remove it from the stream. So you can see here visually what happens is if there's not any hits, not any matches for a given word, then filter will remove that search results object from the output stream. So we'd end up with less objects, as I show here visually. In this particular case, we'll always get a match, but more generally, you don't necessarily get matches. You should notice something else important here with the filter algorithm. It can't transform the type. So the types stay the same. The values stay the same, but you may remove the item from the stream altogether. In contrast, map, which we saw earlier, works on every object or every element that flows through the stream, and it doesn't remove any of them, but it can transform the type and it can change the value, but it can't get rid of any items. In contrast, filter is pretty much the opposite. Filter can get rid of items, but it can't change or transform them. So what we end up there with is a potentially a list of, or a stream of elements that are less than what we got as input. And then what we do is we have collect. Now, collect is an aggregate operation that's actually a terminal operation. And if you looked at the signature for collect, you'd see that it doesn't return a stream. So that's how you know it's not an intermediate operation. If it doesn't return a stream, it's not an intermediate operation, it's a terminal operation. And what collect does is it's going to do two things. It's going to trigger all the intermediate operation processing, and that's because streams are always lazy in the Java Streams framework, meaning that they don't do anything until the terminal operation is reached. Keep in mind, there's only ever one terminal operation, and there must be one in order for things to run. And then what the collect terminal operation does is it works off of something called a collector. And in this case, the collector is actually produced by the toList factory method on the collectors or collectors Java utility class. It's a factory method that creates a list collector that collects the stream of non-empty search results into a data structure, in this case, a list. And later on, we'll see that there's other factory methods like toSet and toMap and so on that you can use to create other kinds of collections besides lists. toList just creates a list that's implemented under the hood as an array list. So what comes back from this particular method will be a list of non-empty search results. And of course, if there are no search results whatsoever, then it'll come back with an empty list. But in this case, it'll come back with a list for each of the words because they're all in the lyrics for the Do, Re, Mi song. So hopefully this gives you a more right brain perspective on what's going on here. Something I should note, however, and we'll talk about this in very short order, the actual way that streams work doesn't work from left to right, top to bottom, which is kind of the way I described this particular visualization. Instead, it works from top to bottom, left to right. And I'll explain more about that as we get more into the details. So it might appear as if we're going from at each row at a time from top to bottom. But of course, under the hood, it actually does it pulling each item from the source down through all the operations once the terminal operation is reached. And the reason it does this, there are two reasons it does this. Number one, it allows something called integrated layer processing optimizations, which improve caching and just speed things up in general. But perhaps even more importantly, it supports something known as short circuit operations. If you're familiar with the semantics of things like logical AND or logical OR in Java, C and C++, or C# for that matter, they have this concept of short circuiting. If once you know whether something is true or false, you don't bother evaluating anything else in the expression. And streams have a similar concept, not quite the same implementation, but similar in terms of the theme. Namely, there's certain kinds of aggregate operations, both intermediate operations and terminal operations, that can stop the processing before you process all the elements in the stream. And there are methods like skip and limit and take while and drop while and find first and so on that can be used in order to define elements or to be able to stop the processing before you go through the whole stream from top to bottom or from left to right. And we'll talk a lot more about that later, but that's why the actual behavior goes top to bottom, left to right, not left to right, top to bottom. If that makes absolutely no sense, do not worry. We will cover it in more detail, and you'll get a lot of chances to try it out when you write your programs and do the assignments later. So that's the end of the visualization of the WordSearcher.findWords method. And hopefully, again, this gives you this more holistic Gestalt perspective on what's happening. I will try as much as possible throughout the slides on streams to visualize things as well as look at source code, because I find otherwise you can get lost in the source code. And the source code is so wonderfully concise and parsimonious that you sometimes miss out on what's really happening under the hood, which is important to get a feel for, especially when you're starting out.